If you're here because some video told you a massive object is barreling toward Earth, I've got good news and bad news. The good news? We're not going to die. The bad news? You just got clickbait. But don't click away, because the real story of 3I/Atlas is actually way more fascinating than any alien theory you've seen. And I'm going to prove it. For the past 5 months, I've been eating, sleeping, and breathing this comet. I've read every paper, tracked every observation update, and even reached out to the astronomers who are directly observing it. And today, I'm going to break it all down for you. No drama, no speculation, just raw, mind-blowing science. But before we dive into what 3I/Atlas really is, we need to talk about something that's flooding the internet right now. Misinformation. Over the past 2 months, videos about 3I/Atlas have exploded across YouTube, racking up tens of millions of views. And their titles usually look something like this. Massive alien mothership approaching Earth. Collision course confirmed by James Webb. Scientists terrified by what they found. I've watched over 50 of these videos. And let me be clear, almost every single one of them is wrong. But honestly, what frustrates me most isn't just that they're wrong. It's that they're wasting an incredible opportunity to tell a story that's actually far more mind-blowing than any alien theory. Instead of diving into the rare nature of interstellar visitors, instead of explaining why 3I/Atlas is one of the most bizarre objects we've ever observed, they slap the word alien on it, crank up some ominous music, drop dramatic CGI, and milk the fear for clicks. But here's the truth. You don't need to fake drama when reality is already this strange. And that's exactly why I'm making this video. I want to take you through the 4 biggest questions surrounding 3I/Atlas. And if you stick with me until the end, I think you'll agree. Reality is cooler than fiction. Here are the 4 questions we're going to explore. What exactly is 3I/Atlas? And why is it so special? Is it really on a collision course with Earth? Spoiler, no, but there's a twist. What's genuinely weird about this object? And what does it tell us about the universe and about us? But before we dive into the first question, there's one core idea you need to understand about astronomy. Honestly, what bothers me most about all those viral, sensational videos isn't just that they're inaccurate. It's that they completely miss the real story. Because this isn't just about a rock flying through space. This is about a visitor from another star system, crossing billions of kilometers, carrying the chemical fingerprint of a place we've never seen, and passing through our solar system in our lifetime. And instead of exploring that, these creators just went with the easy route, fear and aliens. But if you're still watching, I'm guessing you want more than that. So here's what I'm going to do. I'm going to walk you through the 4 big questions that unlock the real story behind 3I/Atlas. And by the end of this video, you'll see why the truth is far more incredible than fiction. Question 1. What exactly is 3I/Atlas? And what makes it so special? Question 2. Is it actually on a collision course with Earth? Short answer, no. But there's a very interesting but. Question 3. What's truly strange about this object? What are the astronomers seeing that most people aren't talking about? And finally, question 4. What does this comet tell us about the universe and about our place in it? But before we dive into all of that, there's one core truth about astronomy you need to understand. And once you do, everything else will make a lot more sense. Imagine this. You live in a quiet rural village. Your entire life, you've only seen familiar faces, your neighbors, your family, people who've been there for generations. Everything feels known, predictable, local. Then one day, a stranger walks past your house. They don't stop. They don't speak. They're clearly from far away, maybe even another continent. And then, just like that, they're gone. That is what 3I/Atlas means to our solar system. See, for the past 4.6 billion years, our solar system has been a tightly knit neighborhood, home to trillions of objects. Planets, moons, asteroids, comets, even dwarf planets. And almost every single one of them was born here, orbits here, and will eventually die here. But 3I/Atlas? It's not from around here. This object is a visitor from beyond, from another star system, potentially hundreds of light years away. And here's the mind-blowing part. Until 2017, scientists weren't even sure interstellar objects really existed. They'd been predicted, sure, mathematically it made sense. When a solar system forms, gravitational chaos ejects countless comets and asteroids into interstellar space. Billions of them, wandering between the stars for eons. But for all our telescopes, all our sky surveys, we'd never actually seen one. Until one suddenly arrived. Its name, Oumuamua, discovered in 2017, it was the first confirmed object ever observed passing through our solar system that did not originate here. It was on a hyperbolic path, meaning it came in once and it would never return. That moment changed astronomy forever. Because suddenly, the idea of interstellar visitors wasn't just theoretical. It was real, tangible, measurable. And it opened the door to a new era, an era where, for the first time, we weren't just looking out at the universe. We were seeing the universe send things back. In 2017, the discovery of Oumuamua, the first confirmed interstellar object ever observed, sent shockwaves through the astronomical community. Why? Because it was unlike anything we'd ever seen. Here's what the data revealed. Its shape was bizarre, long and thin like a cigar, with an estimated length-to-width ratio of 10:1. It had no coma, no fuzzy halo of gas and dust, which most comets develop as they get close to the sun. And most intriguingly, it exhibited non-gravitational acceleration, meaning its motion couldn't be explained by gravity alone. This led some scientists to ask a radical question. Could this be a light sail? As in, an artificial probe, possibly designed by an advanced civilization? We didn't get answers. Oumuamua passed by too quickly and disappeared before we could study it further. To this day, it remains one of the most puzzling objects ever detected. Then, in 2019, came a second interstellar visitor, 2I/Borisov. But this one looked much more normal. It had a clear coma, a long tail, and behavior typical of a textbook comet. In a way, it was almost boring compared to Oumuamua. And just when we thought we might not see another interstellar object for decades. July 1st, 2025. The ATLAS telescope in Chile spotted something strange. A small dot of light moving in a way that didn't match anything local. Initial observations showed a velocity of around 61 kilometers per second relative to the Sun, fast enough to escape the solar system forever. A hyperbolic trajectory, meaning it's not in orbit. It's just passing through, and it won't be coming back. And while its exact composition wasn't clear yet, it was interesting enough that within days, telescopes across the planet began tracking it. This was no ordinary discovery. It was named 3I/Atlas, the third confirmed interstellar object in human history. And in just a few short weeks, it became one of the most observed objects of 2025. From NASA's infrared arrays to amateur backyard scopes, everyone was watching it. Because here's the perspective. Out of the billions of celestial bodies we've cataloged, planets, asteroids, comets, only 3 have ever been confirmed as interstellar visitors. 3. In all of human history. And one of them is here, right now. We are not reading about it in a textbook. We are living through it, in real time. Okay, so we've established that 3I/Atlas is the third confirmed interstellar object humanity has ever discovered. That's cool. But what makes it stand out from the two that came before it, Oumuamua and Borisov? This is where the story starts to get really interesting. Size and composition. The Hubble Space Telescope was among the first to observe 3I/Atlas, and it estimated the object's nucleus to be somewhere between 0.5 and 5.6 kilometers in diameter. Not massive, but not tiny either. But then, in August 2025, something surprising happened. The James Webb Space Telescope turned its state-of-the-art instruments toward 3I/Atlas. And what it found completely caught scientists off guard. It detected an exceptionally high concentration of carbon dioxide, far higher than what's typically seen in comets from our solar system. Water, ice, and vapor, but in lower quantities than expected. Carbon monoxide, in significant amounts. Carbonyl sulfide, a sulfur-based compound. Cyanide, confirmed by the Very Large Telescope in Chile. And even traces of nickel vapor, yes, metal vapor. Now, this isn't weird in the sci-fi alien tech sense. But scientifically, it's incredibly strange. Why is it so rich in carbon dioxide? The leading hypothesis is that 3I/Atlas formed in a completely different kind of environment, somewhere far outside our solar system, where the chemical makeup of its parent star system was unlike anything we see here. Or maybe it's simply much, much older. Age and origin. And that brings us to perhaps the most mind-blowing part of all. Based on its current velocity and trajectory modeling, researchers believe 3I/Atlas may have originated from what's known as the thick disk of the Milky Way, a region populated by some of the oldest stars in the galaxy. If that's true, then this object could be anywhere from 7 to 8 billion years old. Let's put that in perspective. Earth is 4.5 billion years old. The solar system is 4.6 billion years old. 3I/Atlas may be 7 to 8 billion years old. That means this comet may have formed before our sun even existed. It has likely spent billions of years drifting through interstellar space, passing star after star, system after system, watching the birth and death of entire solar systems, before, by sheer cosmic coincidence, crossing paths with us in the year 2025. That's not science fiction. That's the kind of cosmic reality that makes alien theories seem small by comparison. And this is just the beginning. Because question 2 is where the internet really got it wrong, big time. Shall I continue with question 2? Is 3I/Atlas on a collision course? Alright, let's address the big question everyone keeps asking. Is 3I/Atlas on a collision course with Earth, or with any planet at all? The short answer, no. The long answer, let me show you the actual data. Debunking with evidence. Here's the official trajectory from NASA's JPL Horizon system, widely regarded as the gold standard for orbital mechanics and prediction. According to the latest orbital calculations, perihelion, the closest point to the Sun, will occur on October 29, 2025, at a distance of $1.36. $1 equals the distance from Earth to the Sun. For context, Mars orbits at roughly $1.50. Earth is at $1. So how close will it come to Earth? $1.80, or about 270 million kilometers away. To put that into perspective, that's nearly 700 times the distance from Earth to the Moon. It's actually farther than Mars at its closest approach to Earth. As for Mars itself, the closest approach between 3I/Atlas and the Red Planet will be on October 3, 2025, at $0.018, roughly 2.7 million kilometers away, according to NASA. The European Space Agency, ESA, estimates that number even higher, around 29 million kilometers. Let's not forget, Mars has a diameter of just over 6,700 kilometers. So even at its closest, this comet is passing at a distance of more than 400 Mars diameters. Here's what the space agencies are saying. NASA states clearly, Comet 3I/Atlas poses no threat to Earth. ESA confirms, it poses no danger to Earth or any other planet. Why are people saying it's on a collision course? So, if the science is clear, why do some videos still claim that it's heading straight for us? The answer comes down to three common tactics used in clickbait content. Cherry-picking language. Taking phrases like, close approach to Mars, and twisting them into collision course. Misrepresenting orbital refinements. ESA used data from a Mars orbiter to improve trajectory accuracy, standard practice, but clickbaiters frame it as a sudden deviation. Blurring the line between theory and fact. Referencing speculative ideas from figures like Harvard professor Avi Loeb, who published a paper exploring alien possibilities, then presenting that speculation as scientific consensus. But here's the reality. There has been no unexpected deviation. Trajectory refinements are routine procedures. The orbit of 3I/Atlas is fully predictable using basic physics. This is the difference between science communication and fear-based storytelling. You want receipts? Let's put them side by side. On one side, sensational headlines, scary music, dramatic CGI. On the other hand, verified NASA data, orbital plots, and official statements. It's not hard to see who's telling the truth. So no, 3I/Atlas is not coming for us. But that doesn't mean it isn't strange. And question 3 is where things take a turn, because as you'll see, there's something genuinely unusual about this object. This is where things start to get really interesting. Because now, we're stepping into real scientific mysteries, not conspiracies, but genuine puzzles that astronomers are still trying to solve. The early activity mystery. One of the first strange discoveries about 3I/Atlas came from an unexpected source. TESS, the Transiting Exoplanet Survey Satellite. TESS had been observing the region of sky where 3I/Atlas would later be discovered. And when astronomers reviewed that older data, they found something surprising. 3I/Atlas was already active, meaning it was outgassing and forming a coma, as early as May 2025. Here's the catch. At that time, the object was still 6.4 astronomical units from the Sun. That's nearly twice as far as where most comets begin to show signs of activity. For comparison, typical solar system comets start to outgas at around 3 to 4 Australian dollars. 3I/Atlas became active at 6 Australian dollars and 40 cents. What does that mean? It means that the ices in its nucleus, likely carbon dioxide and carbon monoxide, can sublimate, turn directly from solid to gas, at much colder temperatures than water ice. In simpler terms, the chemical composition of 3I/Atlas is genuinely different from typical comets. Not because it's artificial or alien tech, but because it likely comes from an alien environment. A different star system. A different chemistry. A different origin story entirely. The rotation puzzle. Here's another strange detail. Observations show that 3I/Atlas rotates once every 16.16 hours. So what? That's not too unusual, right? Well, actually it is. Most comets have irregular shapes, and they tend to tumble chaotically as they rotate. Their outgassing is messy, unpredictable, and uneven. But 3I/Atlas? Its rotation appears to be remarkably stable. We're not entirely sure why. Possibilities include: it might be more spherical than we expected. Its mass may be evenly distributed, helping it rotate smoothly. Or something in its formation history made it unusually balanced. This is what makes real science exciting. The most fascinating mysteries aren't always dramatic. They're subtle. They hide in the data, in the patterns, in the details. The anti-tail illusion. Now, let's talk about one of the most viral and misunderstood observations. Several amateur astronomers reported seeing what looked like an anti-tail on 3I/Atlas. That is, a thin streak pointing toward the sun instead of away from it. Sounds bizarre? Actually, this is a well-documented visual phenomenon. When Earth passes through the plane of a comet's orbit, the trail of larger dust particles can appear, from our point of view, to be pointing in the wrong direction. It's not breaking the laws of physics. It's just orbital geometry and perspective. Mystery solved. But online? That same feature became twisted into claims like, anti-tail defies physics, must be a propulsion system. See the difference? On one side, scientific explanation based on decades of comet studies. On the other hand, wild speculation is designed to confuse or entertain. And this brings us to a deeper point. Science doesn't run away from mystery. It embraces mystery and uses evidence to unravel it. That's what makes this object so compelling. 3I/Atlas isn't just clickbait material. It's a legitimate scientific curiosity, rich in detail, strange in behavior, and full of clues about worlds beyond our own. By now, we've established the key facts. 3I/Atlas is a real interstellar comet. It poses no threat to Earth. And it contains strange, fascinating clues about where it came from. But that leads to a deeper question. Why does any of this matter? Why have I spent 5 months following it so closely? Because 3I/Atlas tells us something profound about the universe. We're not alone, in a scientific sense. Every time a star system forms, it creates billions of asteroids and comets. Most of those stay local, locked into orbits around their parent star. But not all of them. Some get kicked out, flung into deep space through gravitational interactions, collisions, or orbital chaos. Our own solar system has done this. So has Alpha Centauri. So has every other star system. The result? Our galaxy is filled with interstellar wanderers, trillions of them, quietly drifting between the stars. 3I/Atlas is one of those nomads. And the fact that we're starting to detect them at all means our technology has finally become sensitive enough. We're expanding our understanding of how matter circulates within the Milky Way. We're beginning to glimpse the debris field of the galaxy's ancient history. This isn't an alien invasion. This is galactic circulation. And it's beautiful. Time capsules from dead star systems. If 3I/Atlas really is 7 to 8 billion years old, then it's a literal time capsule from the early galaxy. It carries the chemical fingerprints of a star system that may no longer exist. It has traveled through cosmic environments we'll never be able to reproduce. It has witnessed conditions that Earth has never seen. By studying it, we're not just learning about a single object. We're uncovering the history of other solar systems, not just our own. And this is only the beginning. Because in 2026, the Vera Rubin Observatory will begin operations. And when it does, we expect to detect dozens of interstellar objects every single year. 3I/Atlas is not the exception. It's the first wave of a new era in astronomy. We are not just living in the universe. We are now beginning to understand how the universe flows through us. We're standing at the very edge of a new frontier. We are living at the dawn of interstellar astronomy. Before we wrap up, I need to talk about something even more important than 3I/Atlas. And that's misinformation, especially when it comes to science. You might be thinking, it's just YouTube entertainment. No one actually believes that stuff, right? But the data tells a different story. Recent surveys show that nearly 40% of Americans no longer trust NASA. Scientific literacy is declining across many age groups. Conspiracy theories about space are gaining real traction online. And when legitimate discoveries, like 3I/Atlas, are turned into sensational headlines, it contributes to a culture where real science feels boring by comparison. People start to doubt credible institutions, and actual scientific understanding begins to erode. Here's why that's dangerous. If you believe 3I/Atlas is on a collision course, and then nothing happens, you might reasonably think, "Oh, they exaggerated to get views." That might be true. But what's worse is when that turns into, "Maybe all space news is fake." And that's completely false. That's how trust starts to erode. And that erosion affects space exploration funding, science education, and even public policy. How to spot good versus bad sources. So how can you tell the difference between credible science content and content built purely for fear and clicks? Red flags to watch out for in untrustworthy videos. Titles in all caps with words like "terrifying, shocking," or "exposed." No links or citations to real sources. Mixing speculation with facts without distinction. Ominous music designed to manipulate your emotions. Disclaimers like, "This isn't science," but then spending the whole video pretending it is. Green flags in trustworthy sources. Links to actual research papers or official NASA/ESA pages. Clear separation between what we know and what we're still figuring out. Honest discussion of uncertainty and limitations. Real data visuals, not just flashy CGI. Presentation of multiple expert perspectives, not just one voice. Let me be clear. I'm not saying you have to blindly trust everything NASA or scientists say. Healthy skepticism is a good thing. But there's a difference between skepticism and cynicism. Between asking questions and denying all answers. And your best defense in this noisy, confusing world is scientific literacy. The ability to understand just enough science to evaluate claims for yourself. Wrap up. So let's recap what we've learned. 3I/Atlas is the third interstellar comet ever detected by humanity. It is not on a collision course with Earth or with anything else. Its composition is unusual, rich in carbon dioxide, possibly 7 to 8 billion years old. It marks the beginning of a new era in astronomy, interstellar object detection. And most importantly, the real story is far more fascinating than any clickbait version. But beyond the facts, here's the message I want you to take with you. The universe is already mind-blowing. You don't need to make things up. You don't need alien motherships or doomsday headlines to feel wonder. You just need to understand what's truly happening. Think about it. An object from a distant star system, older than our own sun, carrying chemistry from a dead world, drifting through space for billions of years, and by pure cosmic coincidence, passing close enough for us to see it. And we just happen to be living in the first decade where our technology is advanced enough to detect it. If that doesn't give you goosebumps, I don't know what will. What comes next? 3I/Atlas is now heading out of the solar system. By mid-2026, it will be too faint to observe. But the story doesn't end here. The Vera Rubin Observatory is about to come online. We expect to detect dozens, possibly hundreds, of interstellar objects in the coming decade. Each one will be a messenger, teaching us something new about our galaxy. And I'll be here to cover those discoveries. No clickbait, no drama, just real science. If you want to stay informed without getting lost in misinformation, subscribe to this channel. Follow NASA Science and ESA on social media. Learn to evaluate sources critically. And when you see misinformation, share the facts. We're all in this together. And an informed public is a public that can make better decisions about science funding, education, and our future in space. Thank you for spending about 30 minutes with me on this deep dive into 3I/Atlas. I know it's not as sensational as Alien collision incoming. But I hope you'll agree, the reality is even more awe-inspiring. The universe doesn't owe us easy answers or dramatic revelations. What it offers us instead is something better. Truth. And truth, when you truly understand it, is always more valuable than fiction. See you in the next video.